Hello, in this lecture we'll find out the area of a square. In the drawing we have triangle ABC. Angle ABC equals to 90 degrees. Side AB equals to 5 units. Side BC equals to 12 units in its length. Inside this right triangle, triangle ABC, we have square DEFG. And our mission is to find out the area of this square DEFG. So first of all, we will implement the Pythagoras theorem in this right triangle, triangle ABC. So in the right triangle, triangle ABC, here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So if we found out that AC square equals to 25 plus 144, 25 plus 144 is 169, so according to question 1, found out that AC square equals to 169. Here we'll take a root out of this equation, and finally we'll get that AC equals to the square root of 169, that is 13. So AC equals to 13 units in its length. The length of the hypotenuse AC is 13 units. So in the next step, we define this angle, the international angle ACB as alpha, and we will focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. And therefore, the missing angle here equals to beta. In this equation, 90 degrees minus alpha equals to beta. If we add to this equation alpha and the subtract beta, we get that 90 degrees minus beta equals to alpha. Okay. And we have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Again, the sum of the angles on one side of a straight line is equal to 180 degrees. So AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. AC is the straight line, so if we focus on the lower side of the straight line AC at point D here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle here. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees in its side. Likewise, if we focus on the lower side of the straight line AC point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E here? We have this angle that is 90 degrees plus the missing angle plus this missing angle. In total, the sum of those two angles in total they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Okay. So, if we focus on the right triangle EGC, on the right triangle EGC, in the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, according to our definition, therefore the missing angle here equals to beta. Likewise, if you focus on the right triangle ADF, in the right triangle ADF, this angle equals to beta. In the right triangle ADF, this angle equals to beta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle here must be equal to alpha. In the next step, we will focus on the upper side of the straight line BC at point G. Again, we focus on the upper side of the straight line BC at point G here. Which angles we have at the upper side of BC at point G? We have the rule that the sum of the angles on one side of the straight line equals to 180 degrees. That is to say, the sum of the angles on the upper side of the straight line BC at point G here, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point G? We have this angle that is beta. This angle equals to 90 degrees plus the missing angle. The sum of those three angles in total, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on one side of a straight line, or it is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. Okay, in the next step we focus on the small right triangle FBG. On the small right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. So in the drawing we have in total 4 right triangles, 1, 2, 3, and the big right triangle, triangle ABC. And all those 3 right triangles are similar to each other according to angle similarity rule. That is to say, all those 4 right triangles have exactly the same 3 angles, alpha, beta, and 90 degrees. And therefore, all those 4 right triangles are similar to each other according to angle similarity rule. So, for example, we have the big right triangle ABC that is similar to this small right triangle, triangle FBG. So I'll write it down. The big right triangle, triangle ABC is similar, this is the sign of similar, to the small right triangle, triangle FBG. According to angle similarity rule. Okay, and from the fact that the 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that, but before that, we define the length of side BG of the right triangle FBG as x. BG equals to x according to our definition. So what is the length of GC? GC equals to BC minus BG. Again, BC minus BG equals to GC. That is to say, GC equals to BC, that is 12, minus this, minus BC. GC equals to BC, that is 12, minus BG, that is x. So in total, GC equals to 12 minus x. In the next step, we'll define the length of one side of this square DEFG as L. So DE equals to L according to our definition, therefore all the other 3 sides must be also equal to L because of the fact that in any square all the sides are equal to each other. So EG also equals to L, DF also equals to L, and finally side FG of the right triangle of square DFGE is also equals to L. So I repeat again that because of the fact that the right big triangle, triangle ABC, is similar to this small right triangle, triangle FBG, the following relationship exists between their sides. Side BG over side FG of the right triangle FBG, BG over FG must be equal to side BC, BC over AC of the right big triangle, triangle ABC. Repeat again. Because of the fact that the right triangle ABC is similar to the right triangle FBG according to angle similarity rule, therefore the following relationship exists between the sides of the 2 right triangles that are similar to each other. BG over EG in the right triangle FBG is equals to BC over AC in the right triangle ABC. So this is equation 1. So BG equals to x over FG. FG equals to L. And it is equals to BC equals to 12. according to what is given as the equation, over AC. AC equals to 13, according to what we have already found out, according to the Pythagoras theorem. So in conclusion, found out that according to equation 1, x over L equals to 12 over 13. Here we multiply this equation 1 by L, and we get that according to equation 1, x equals to 12 over 13 times L. And we also know that the right big triangle ABC is similar to this right triangle EGC. Repeat again. The right big triangle ABC is similar to the right triangle EGC. Repeat again, the right big triangle ABC is similar to this right triangle EGC according to angle similarity rule, and therefore the following relationship exists between the sides of those two right triangles that are similar to each other. GC over GE in the right triangle EGC equals to AC over AB in the right triangle ABC. Repeat again. Because of the fact that the right big triangle ABC is similar to the right triangle EGC, therefore the following relationship exists between the sides of those two triangles that are similar to each other. GC over GE in the right triangle EGC is equal to AC over AB in the right triangle ABC. GC equals to 12 minus x over GE. GE equals to L. And it is equals to AC. AC equals to 13 over AB. AB equals to 5. Again, AB equals to 5, according to what is given as the question. So in conclusion, found out that according to equation 2, 12 minus x over L equals to 13 over 5. Here we cross multiply this equation 2, and we get that according to equation 2, 5 times 12 minus x equals to 13L. We'll open the brackets on this side of equation 2, and we get that 5 times 12 is 60, 5 times minus x is minus 5x, equals to 13L. Here we have x in this equation 2, and we already found out that x according to this equation 1 equals to 12L over 13. So we substitute x in this equation 2 by the value of x that we found from this equation 1. We do it now, and we get that 60 minus 5x, and x according to equation 1, this equation 1 equals to 12L over 13, and it is equals to 13L. So we found out actually that according to equation 2, here we have minus 5 times 12L is minus 60L divided by 13 equals to 13L. And again, I found out that according to equation 2, minus 60L over 13 equals to 13L. So here we will add 60L over 13, and then we subtract 13L from this equation, and we get that 60 minus 13L equals to 60L over 13. Here we multiply this equation 2 by 13, and we get that 60 times 13 equals to 780 minus 13L times 13L is 169L, and it is equals to 60L. Here we'll add to this equation 2 169L, and we get according to this equation 2, 780 equals to 60L plus 169L equals to 229L. So in conclusion, we found out that according to this equation 2, 780 equals to 229L. Here we divide this equation 2 by 229, and finally we get that according to this equation 2, L equals to 780 over 229, and 780 over 229 is equals to 3.406113. our mission is to find out the area of this square DEGF. So the area of square DEFG will be equal to the size of one side square. That is to say, it is L square. The area equals to L square. We just write down from that L equals to 3.406113, and therefore L square equals to 3.406113 square. And 3.40613 square is equal to 11.6016. In conclusion, found out that the area of square DEFG is equal to 11.6016 square units. And that is the answer to the question. I repeat again. The area of this square DEGF is equal to 11.6016 square units. So, in the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEGF. So, in the drawing, we have a right triangle, ABC, and inside this right triangle ABC, we have a square DEGF. In addition, we know that the length of side AB of triangle ABC is equal to 5 units. Side BC equals to 12 units in its length. This is angle ABC, it is a right angle, it is equal to 90 degrees. Again, our mission is to find out the area of this square DFGE. So, first of all, we implemented the Pythagoras theorem on the right big triangle ABC. According to the Pythagoras theorem, in the right big triangle ABC, in any right triangle, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. And again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 13, therefore BC is 12. Here, BC equals to 12 units in its length. Therefore BC square is 12 square, that is 144. So in conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So we found out that AC square equals to 169. We took a root out of this equation and finally found out that AC equals to 13. That is to say, the length of the hypotenuse AC is equal to 13. is equal to 13 units in its length. In the next step, we define this angle ACB as alpha, and we focus on the right triangle, triangle ABC. In the right triangle, ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here, must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is equal to 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. But we define 90 degrees minus alpha as beta, therefore the missing angle here equals to beta. Okay, then we also have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. The hypotenuse AC is one side of a triangle, it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point Z, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is right angle, plus the missing angle, in total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size. Likewise, if we focus on the lower side of the straight line AC at point E here, the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point E? We have this angle that is right angle, plus the missing angle here, in total it must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size. Okay. So we have here in the right triangle in BC we have this angle equals to beta, this angle equals to 90 degrees, this angle equals to alpha. So in the right triangle GEC, this right triangle GEC, this angle equals to alpha, this angle equals to 90 degrees. Therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle equals to beta. Okay. So if we focus on the upper side of the straight line BC here at point G, so at the upper side of BC at point G, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G? We have this angle that is beta, this angle that is 90 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. If we focus on the right triangle FBG, on the right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. Then we focus on the right small triangle DFA. In right triangle AFD or DFA, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. So in the drawing here we have 4 right triangles. 1, 2, 3, and the right big triangle, triangle ABC, is the 4th triangle. On those all 4 triangles, all the angles are correspondingly equal to each other. In each triangle, we have three angles, alpha, beta, and 90 degrees. And those are the three angles in all those four triangles. Therefore, all those four triangles are similar to each other according to angle similarity rule. Repeat again, all the four triangles in the drawing are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to the small right triangle FBG. Repeat again, the big right triangle ABC is similar to the small right triangle FBG. According to angle similarity rule. And from the fact that the big triangle ABC is similar to this small triangle FBG, we will derive that the following relationship exists between those two similar triangles. We derive that BG over FG, again BG over FG in the right triangle FBG equals to BC over AC in the right big triangle ABC. Repeat again, we derive that BG over FG equals to BC over AC. BG is X, FG is L, BC is 12, and AC is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that X equals to 12 over 13 times L. Likewise, the right big triangle ABC is similar to this triangle AGC. Again, triangle ABC is similar to this triangle AGC. Repeat again, triangle ABC is similar to triangle AGC according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that GC over GE in the right triangle EGC is equals to AC over AB in the right triangle ABC. Repeat again. We will derive that GC over GE in the right triangle EGC equals to AC over AB in the right triangle ABC. GC is 12 minus X, GE is L, AC is 13, and AB is 5. So in conclusion, according to this equation 2, we found out that 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and finally found out that 5 times 12 minus X equals to 13L. We open the brackets in this side of this equation 2, and finally found out that 5 times 12 is 60, and 5 times minus x is minus 5x, that is equals to 13L. So here we added, we subtracted 13L, and we added 5x to this equation, and finally we found out that, again 60 minus 5x equals to 13L. Okay? According to this equation 2, 60 minus 5x equals to 13L. So we have here x in this equation 2, but according to equation 1, x equals to 12 over 13 times L. So we can substitute x in this equation 2 by 12 over 13 times L from this equation 1. We actually did it, and we found out that actually that's 60 minus 5x. So it is minus 5, and x equals to 12 over 13 times L. So we substitute x here by 12 over 13 times L. And it is equals to 13L. Okay, so 60 minus 5 times 12L is minus 60L over 13 equals to 13L. Repeat again. Actually found out that 60 minus 60L over 13 equals to 13L. Here we multiply this equation 2 by 13. And we found out actually that, but first of all, so 60 minus 13, we subtracted 13L. Here we subtracted 13L and added 60L over 13 to this equation simultaneously. And we found out that 60 minus 13L equals to 60L over 13. So here we multiply this equation 2 by 13, and finally found out that 60 times 13 is 780, minus 13L times 13 is minus 169L, and it is equals to 60L. So here we added 169L to this equation 2, and finally found out that 780 equals to 60L plus 169L equals to 229L. So in conclusion, found out that according to this equation 2, 780 equals to 229L. So here we divided this equation 2 by 289, and finally found out that L equals to 780 over 289. 780 over 289 is 4.40613. So in conclusion, found out that the length of one side of this square DEGF, it is equals to L equals to 3.40611 square units. Again, L equals to 3.40611 units. So what is the area of this square ABCD? The area equals to one side squared. One side is L, therefore one side square is L squared. So the area of square DEFG equals to L squared. L is 3.40611, therefore L squared is 3.40611 squared. And 3.40611 squared is equals to 11.6016. So in conclusion, found out that the area of this square DEGF is equals to 11.6016 square units. Okay, thank you very much.